NumPy library is one of the most widely used Python libraries. NumPy is the fundamental package for scientific computing in Python. It provides support for large, multidimensional arrays, and matrices, along with a collection of high-level mathematical functions, to operate on these arrays. It is widely used in scientific computing, data analysis, and machine learning tasks, because of its efficiency and ease of use. Today, we will learn NumPy, by performing sales analysis on a sales data. So, let's start. We are going to use Google Colab. You can use any Python compiler you like. Google Colab allows us to share Python code with you easily. Today, we will learn to upload a CSV file into the Google Colab virtual memory. Then we will read that file using NumPy and store it into an array. We will learn some data cleaning. We will learn to normalize data. Perform some statistical analysis. Some sales analysis such as best-selling product, or product category. And finally, we will display some of this data, and analysis, on charts, using Matplot library. First of all, we will import the NumPy library to our Python project. Secondly, to upload the CSV file from our computer, we will import the files library. This is the data that we will use today. These are the sales of January 2023, of one of our stores. We can now upload our data set. Use files.upload command, to upload any file, to Google Colab. Run the code, and select the file you want to upload. Let the Google Colab upload the file to its virtual memory. We'll add a new code block, to avoid uploading file repeatedly. Now, we will store this uploaded file, in a variable, using NumPy library. In the arguments, first we will provide the name of the CSV file that we want to read. Secondly, we will provide the delimiter, which separates each column. You can get this information from the CSV file you want to read. Just open the file in a notepad, and look for a symbol separating columns, like comma. We will skip the headers, which are in the first row. We can also define the data type of our CSV file. We are using plain text file, therefore the data type will be none. Next, we will provide the names of our columns. We can simply copy the header row of our CSV file, and paste it here. Then we can add apostrophes around each column name. We also need to provide the encoding information. Our file contains Unicode encoding, which we will enter here. Now, we can print the variable data, to confirm that the code is working, and the data has been loaded accurately. As you can see, all the columns, and data within, has been loaded properly. We can perform data cleaning using NumPy library. For example, there are two columns, which have numeric data: sales, and advertisement. We can remove blanks from these columns, and convert them into numbers using NumPy. Let's create a new variable, and store sales column in it, removing any null values. Provide the name of the column you want to remove null values from, here. Let's do the same to the advertisement column. Let's add another code block. We can use the NumPy library to normalize data as well. Data normalization consists of remodeling numeric columns to a standard scale. We will exclude from sales data the mean of sales data, and divide the answer by its standard deviation. We will do the same to the advertisement data. We can perform some statistical analysis on our data, such as mean, median, standard deviation, etc. We can print these results using the print command. We can combine strings using plus sign. Remember to convert numeric data to a string before combining it using the plus sign. Run the code to see the results. Let's add another code block. We will now create a variable where we will store all unique products. In our original table, products are repeating. Here we will remove duplicates and generate a list of unique products. We will create another variable to store products. We will loop through the unique products and one by one store them here. We will create another variable where we will store sum of sales against each product. Let's loop through the products. Here, we will calculate the total sales against current product in the loop from main table. We will perform the summation on data, where product in data is same as current product in loop. Here we are simply entering a where clause on product in the table named data. Here we will tell Python to sum the sales column. We will then store the current product in list P. And the sales against this product in the list S. We can print these lists to verify their results. And here are the results. Similarly, we can also calculate sales by category of products. Let's copy this code to another code block. Let's change products to categories. Let's select the category column from data. We will also change the names of these lists. We will also make changes to our loop. Change this from product to category as well. Make some changes here as well. Now, let's run the code, and see the results. We forgot to replace product with category in our where clause, due to which it is looking for product instead of category. Now it is giving the correct results. Let's further our analysis a bit, by creating another code block. Create a variable, and store the maximum value from list of sales by products. Create another variable, and store the index of that maximum value. Let's print the name of product with highest sales. Get the product on this index. Now, copy this code, and paste it below the existing code. Make changes to find out the category of products having highest sales. Now, run the code, and see the results. Our best-selling product is nightgowns, and the best-selling category is accessories. We can also perform basic mathematical operations, such as average. Let's calculate average sales. We can print the average sales, using the print command. So, here is the average sales. We can calculate average sales based on conditions as well. For example, let's calculate the average sales of a specific product. Here we will add a condition based on product column. The product should be nightgowns. Let's print the outcomes. Run the code, to see the results. Finally, let's import pyplot library, to create some visualizations of our sales analysis. Let's plot sales and advertisement data, on a scatter chart. First, we will store sales data in variable X. Then, we will store advertisement data, in variable Y. Now, we will create a scatter chart, using the X and Y variables. The data will tell us overall relationship between sales and advertisement expenses. which seems to be positive. We can also use the normalized data to perform the same analysis. Let's create another scatter chart, but this time, instead of X and Y, we will use the normalized data. Normalized data was generated previously, if you may recall. This will display the exact same chart, but with numbers ranging between -2 and +2. Another chart that we can display is sales by product. We will create a horizontal bar chart using product and sales variables. These were also generated previously. The chart will contain following products and their corresponding sales values. Let's generate the chart. These are all the products and their total sales during the month. Similarly, we can also display sales by product categories, which were also generated previously. We will use variables that hold product categories and their corresponding sales values. Thanks for watching. We hope you liked our tutorial. Don't forget to like and subscribe for more tutorials and updates.